So we continue with Euclidean geometry. Euclidean geometry, we are going to do what we call a proportionality theorem. Okay, what is the proportionality theorem? It says that when you have a triangle ABC, okay, and then you construct a line DE, and that line will be parallel to BC, okay? So you have a triangle ABC. Then you construct a line parallel to BC, and then you call the point here D, and then this point you call it E. And then you can give it any point according to the question they can give you. So the proportionality theorem says if you have a line parallel to the base of a triangle, you have to know that the side A divided by the side AD over BD or DB will be proportional equal to the side AE divided by EC, or and then equal also to DB, or no, sorry, to AB, proportional to AB equal to AB divided by AC. So when do you use a proportionality theorem to get this equal or proportionality here? You need first to see if you have angles that are lines that are parallel. Once you have a parallel line, then you will be able to do a theorem that we call a proportionality theorem. So today I'm going to focus on the proof of this theorem. How to prove this theorem. But first of all, I want to show you something here. If you have a triangle like this, the triangle is the ABC. If you make this is the head of your triangle, this becomes the base. So if you draw a line here, this line will be the height of a triangle, and this side you call it what? A base of a triangle. Okay? So if, for example, I choose for example, I choose B to be the head. Even though I turn the triangle, so I have to say this is my the head of a triangle, and this will be represented a base. So if I draw a perpendicular, I will draw something like this. Okay? So this is my base. So it depends how you see which one you choose as your base. Okay? So this is a perpendicular, and this became the height. Okay? Because some people, they want only to see a base, you see, on the top here. Like, because when you're looking at the board, you see this is on the top, so okay, this is my height. This is my height, and this is the base. No. You can say, you can turn the triangle where you find this is your head, and you choose this as your base. Or you choose this is your head, and this became what? The base of a triangle. So if you draw a line here, and this became a height, and this will be your base. What is your base here? The base will be the side AC. Now, another thing I want to show you about a triangle, if you have a line like this is a line, then you have a triangle, because this is a line AC. Then you say, okay, I want my triangle to be this side, so BC. So, and you have this triangle, and this is the head D. So if this is your ground, the height of a triangle will be drawn here. So the height of a triangle is not means you must always draw it to touch the base. No. It depends of the ground. It's always perpendicular to what the base actually is the ground. So you can draw a long line here, and then, so this is your ground. Can you see? This is the soul. Then you take from the head here, and this is your height. Can you see? So if, for example, I can turn it like this, and I have, this is my ground. This is my ground. Then I have a triangle like this. So this is A, B, C, and a D. So I have to look at, because here the perpendicular will not work. So the perpendicular to this ground, the 90 degrees will be here. So you can see perpendicular from the angle of 90 degrees. Okay. So this became your height, and the base will be this one. So when you want to find the area of the triangle, area of a triangle B, the head D, and the C will be 1/2. The base is what? The height is H multiplied by the base, which is what? BC. That will be the area of a triangle BDC. Okay. So now, how do you prove this theorem? Remember, we have a basis here. We have, our base will be AD, DB, AE, EC, AB, and the AC. Okay. So now let's draw the height. So the height of this, let's start from this side. Let's start from here. So this, if we say AD, let's start from the base AD. Okay. So we look at which triangle? A, D, E. So E is our head, the head of a triangle. So the perpendicular here will be at 32 degrees. So I got 32 because I calculated. So we can draw, this is the height. Okay. So that is the height here. Okay. So if this is the height, this will be our base. So we can call this height H. And then we have a perpendicular there. All right. So now, there we go. We looking at this base now, DB, and the height is still the same. Can you see? Because the ground because the AD is our ground, okay? It's our base. So the line AD is continuing to be. So this is our base, which means the height is still the same. So we have to create a triangle with the same head, which is a E. So what do? You create another triangle here. The triangle will be a triangle. Okay. So they will actually give you another triangle where you construct another one. You will construct, so you know why I'm using another color. And when you are doing a Euclidean geometry, you must make sure that you have a blue pen and a black pen, so you see what you add and what was not there. Okay, so now we have a triangle. Now we have a triangle with a base dB and the height is still the same h. Now let's come to the base. Our base, if it's what? AE. Okay, AE means what? When we have a AE, our base will be this one, AE. We're gonna use the triangle ADE. There we go. There's a triangle ADE. Alright, so we need to get 23, okay, 26. So our height will be here. Alright, so this is our height. There we go. Let me choose another color. So that will give us a good thing. So we need another color so we can make a difference. Okay, let's get green. So we have this. All right, so we can call this now. We can call this a height, what we can call this height K. But let's draw another triangle here already, since we have same head here. So with a base now, EC, okay? So there we have this. All right. No. Let me move it to this corner. All right. All right. Yes, there we go. So now we have a triangle EDE, but the height is still K. Let me do it. That's the height. This height, we call it K. So once you have this, you made it. It become easier. So what I'm going to do here, now I have to prove this triangle. So what you do first, you have to calculate the area of all this triangle. Let's start by the area of a triangle with a base AD, so will be AED. AED. So we'll have a 1/2 as the formula of the area. Our height is what? H. Okay. And the base will be multiplied by AD. And then we move to the area of a triangle. Now we have, with the same head, the head of a triangle, we have a D, E, B. So we have a 1/2. The height, remember, the triangle is here. This is the base, and then the height is still H. And then we have the base, what? B, D. Now let's move to the triangle. The triangle what? The triangle, we can move to a triangle, this one now. The triangle with a head, what? D. So we call it the area of a triangle, what? D, A, D, E. So this will be 1/2. The height is what? K. And the base, because the height touch this line AD. So we have AE, sorry, multiplied by AE. Then we move to the area of a triangle. Now, still the head is D. We say E, D, C. The height will be what? K. And then here we have a EC. All right. Then by conclusion, we can find that this is obvious. So AB will be, because we're in the same triangle, it's going to be equal to AB divided by AC. All right. So now, what we're going to do right now, it's very simple. We look at, since there is a parallel here, we find that D, E is parallel to BC. So if we take the ratio of the area of a triangle A, E, D over the area of a triangle D, B, okay? So, because of the parallelism here, this will be equal to the area of a triangle ADE over the area of a triangle EDC. All right. Now, let's substitute this by the area. What is the area of AED? It's 1/2 H multiplied by H, the height multiplied by AD divided by the area of a triangle DEB, 1/2 H the area of this will be 1/2 over ADE. There is it, go. ADE, it's K multiplied by AE over 1 over 2, the area of EDC, which is 1 over 2K, multiplied by EC. So you can see that 1 over 2 divided by 1 over 2 you cancel, H divided by H you cancel. So what will remain there, it's AD over DB. So you can write it DB, or let me just write as it's there, DB. And here also, so cannot get confused, because the DB and the DBD it's the same. So this will be equal, you cancel here and you cancel here, K divided by K is AE divided by what? EC. So you can see these are the same. Therefore, this will be equal to AB, because that is what is remain over AC. So AB over AC. And then it can be also, because these two are parallel, you can also say BC over DE. So this is how you prove actually the theorem of a proportionality theorem. Okay. So the next theorem we'll do here, it's called similarity. How you can find the two triangles are similar. The triangle can be different, but with the size are different, but the triangle can be the same. Okay, so this is really very, very simple. You have just to go one by one and looking at one line. You can even repeat it and you see how we did it. So we move from here. Thank you.